The previous video discussed finding conversion units within the metric system. And they're all based on the power of 10, so they're pretty easy to find once you get the hang of King Henry died by drinking chocolate milk. We're now going to use a way of converting called dimensional analysis, and this is not the same thing as you've used before. However, this dimensional analysis skill will carry you through many chapters in chemistry. So even if you think you know a better or a more simple way to do this, trust me when I say you do need to know how to do this. This is what an example of one of the easier problems would look like. For instance, how many inches are in 2.85 centimeters? Well, the first thing you're going to want to do is find out either how many inches are in a centimeter or how many centimeters are in an inch. And it doesn't really matter which direction you go with this because it's an equivalent statement. It doesn't matter if you say 1 inch equals 2.54 centimeters or 2.54 centimeters equals 1 inch. It's an equivalent statement. Equivalent statement. And there's two different ways we could write an equivalent statement. We could write it as 1 inch has 2.54 centimeters, or I could say 2.54 centimeters contains 1 inch. Either way, it is just fine. As long as whatever's in the numerator is the same thing as what's in the denominator, you have an equivalent statement. And these equivalent statements will carry you through dimensional analysis. This is one of those English to metric conversions I do expect you to know. Only the metric to metric conversions use the base 10. If it's English to metric or within an American system, you got to know those numbers. And I'm not going to ask you to memorize any of them except the one I just put a star by. That 1 inch is equal to 2. Now that you have found your conversion statement, or rather your equivalent statement, you now need to write down what is given to you in the problem. And in this problem, we have 2.85 centimeters. That's where we start. Then we're going to draw a horizontal line. Now draw a vertical line. A lot of students call this the T-chart thing. It's simply just dimensional, I'll try to say that again, dimensional analysis. And I'll show you what all these lines and stuff mean. The most important part of this is you do need to chase this unit down. You see this unit right here, this centimeters unit? Right there, centimeters. That's the unit we're going to be chasing down there. Watch. The reason we do that is because that will allow these units to cancel out. See, a centimeter divided by a centimeter is 1. It's the same thing as saying A divided by A, and that equals 1. This big horizontal bar, this horizontal bar is like a fraction bar. It represents division. This vertical bar, right there, that represents multiplication. It's just an easier way to write a bunch of fractions, and it keeps them all in line. Now that you've chased the unit down, you now want to write the unit you're trying to get to, which in this case is an inch. Now that you have that done, now all we have to do is stuff the numbers from our conversion ratio or our equivalent statement into the dimensional analysis. So the 1 comes down there and the 2.54 there. Now we're ready to simply do the math. This statement, by the way, is exactly the same thing as this statement. It's just a couple of fractions. And I don't think it looks as intimidating. Well, maybe once you get the hang of it, it doesn't look as intimidating. So what you need to do is remember that underneath this first number, 99% of the time, is simply going to be a 1. So we don't write it. We can ignore it, just like there's a 1 there. We don't really need that. Our centimeters have canceled. We're left with the unit we want. If you look at it over here on the grid that I drew, the centimeters cancel. We're left with the unit that we want, inches. Now, provided you can use your calculator correctly, the rest of this should just fall right into place. And you end up with this number. Does that mean we're done? No, it wouldn't be that easy. Remember, all measurements contain both a number and a unit. And the number has to pay attention to significant figures. Our initial measurement was 2.85. How many sig figs are there in 2.85? That is correct. There's 3 sig figs. So our answer should also have 3 sig figs. Recall, conversion units are exact numbers and we do not use them when dealing with significant figures. So we want to round this number to 3 sig figs, and I only care about those first 3. Now are we done? Nope, we still need our unit. Centimeters. Any questions? Make sure you jot those down. I have some more problems to practice with you coming up.